Assalamu alaikum students. Now welcome to the world of physics. Today our topic is speed and velocity. As I have told you in the previous lecture about distance and displacement, just like that, speed and velocity are terms. Speed is related with distance and velocity is related with displacement. How they are related with uh, distance and displacement? Speed can be defined as rate of change of distance, that is called s divided by t, and speed is denoted by v without an arrow. Velocity is defined as rate of change of displacement, v with an arrow and s with an arrow. Here v is showing speed, s is showing distance, so both are having no arrow. Here v is showing velocity, s is showing displacement, and both has an arrow over it. So speed is defined as rate of change of distance, or we can say that measurement of distance covered with passage of time is called speed. Speed is a scalar quantity because it does not need direction for its explanation, and its unit is meter per second. Speed is defined as rate of change of distance. It is a scalar quantity and its unit is meter per second. Now we are going to define here different terms related with speed. These terms are uniform speed, average speed, and instantaneous speed. So the first term is uniform speed. Uniform speed. The second term is average speed, and the third term is instantaneous speed. Now I am going to define all these three. First of all, uniform speed. What is uniform speed? If a body covers equal distances, in equal intervals of time, it is said to be moving with uniform speed. For example, I am telling you a table in which first of all we will write down the distance, then we will write down the time, then we will calculate speed. So if a body is covering 3 meters in 1 second, its speed is 3 meters per second. If the same body is covering 6 meters in 2 seconds, then again the speed is 3 meters per second. If the same body is covering now 9 meters in 3 seconds, again 9 divided by 3 is equal to 3 meters per second. Now the same body is covering 12 meters in 4 seconds. Again 12 divided by 4 is 3. So 3 meters per second is the speed of the body. In all these examples, the body is covering same distances in the same intervals of time. Means if it is covering 3 meters in 1 second, speed is 3 meters per second. Now the distance is doubled, time is also doubled. So it is again 3 meters per second. Distance is tripled, time is tripled, again 3 meters per second. Distance is 4 times increased, time is 4 times increased, again 3 meters per second. So equal distances are covered in equal intervals of time, then the speed of the body is said to be uniform. The second term is average speed. Average speed is denoted by these triangular brackets. Average speed is defined as the total distance covered by a body divided by total time taken by the body. So total distance covered by the body divided by total time taken by the body, this is called average speed. For average speed, we take total distance divided by total time. Next comes now instantaneous speed. Instantaneous speed is a term which is the speed of an object at a particular instant of time. So for the speed of an object for a particular instant of time, we can take speed with some limit. So limit is taken that delta t approaches 0. Delta t approaches 0 means that we are taking so small time that it approaches 0, and this distance divided by time, this is called instantaneous speed. And instantaneous speed is defined as the speed of an object at a particular instant of time. Now I will define velocity for all these with all these terms. Like I will define first of all uniform velocity, then I will define average velocity, then I will define instantaneous velocity. So define all these terms as velocity is defined as rate of change of displacement or displacement divided by time. Velocity is basically a vector quantity because it needs direction for its explanation. It is a vector quantity and its unit is same as that of speed, which is meter per second. Now uniform velocity, average velocity, and instantaneous velocity. We have to define all these terms. First of all comes uniform velocity. Uniform velocity is defined as if a body covers equal displacements in equal intervals of time, then the velocity of the body is uniform. If a body is covering equal displacements in equal intervals of time, then the velocity of body is uniform. Uniform velocity, and one more term I will define over here is called constant velocity. Uniform velocity is somehow different from constant velocity because there is some difference of direction. For uniform velocity, direction in the same direction is not required, but for a body to move in a constant velocity, magnitude as well as direction should be same. For a body to have uniform velocity, magnitude should be same, but direction cannot be same. But for a body for moving in constant velocity, magnitude as well as direction should be same. For example, a freely falling body is moving with constant velocity because the magnitude as well as direction of the body, a body moving on a straight line should have a constant velocity because its magnitude as well as direction are same. Next term is now average velocity. Average velocity is defined as total displacement divided by total time. So total displacement divided by total time is called average velocity. This is the definition of average velocity, the total displacement divided by total time. Next term is now instantaneous velocity. What is instantaneous velocity? Instantaneous velocity means the velocity of an object at a particular instant of time. The velocity of an object at a particular instant of time is called instantaneous velocity. For example, we can say that velocity is instantaneous when we take limit that delta t approaches 0, delta s divided by delta t. Delta s is change in displacement. Limit delta t approaches 0 means we have taken such a small piece of time that is approaching 0 seconds. So instantaneous velocity is defined as the velocity at a particular instant, and its equation is limit delta t approaches 0, del s divided by del t. This is called instantaneous velocity. Now At uniform velocity, the average and instantaneous velocity become equal. If the body is moving with uniform velocity, then its uniform velocity is equal to average velocity, and average velocity is equal to instantaneous velocity. It will have all these three values equal to each other only for a body moving with uniform velocity. Now there is one more difference between velocity and speed, and that difference is that speed can never be negative. Speed can never be negative. This is a very important difference, that speed can never be equal to negative, but the velocity can be negative. How it is possible? Because for speed we always need increase in distance. Either distance increases or distance remains same, but it can never decrease, so speed can never be negative. Whereas for velocity, if we change the direction of displacement, obviously if displacement is changed in direction, it becomes negative. If displacement is negative, then velocity will be negative. So this is very important difference between speed and velocity, that speed can never be negative and velocity can be negative and can be positive. Thank you very much.